Newton's first law. An object at rest will stay at rest. Here's a free body diagram with the normal force acting up on the ball and the gravitational force acting downwards on the ball. Here's an object that is at rest and will stay at rest. An object in motion will stay in motion in a continuous straight line at constant speed and direction. Here's a free body diagram with the applied force acting equally to the left and right and with the normal force balanced by gravity. Because there is an applied force, this ball is moving in a continuous straight line at constant speed and direction. If a force interrupts an object, the object will change direction or speed. Here's an interrupted force acting on the ball, causing it to change speed and direction. Newton's second law. The total amount of force of an object is the same as the object's mass times its acceleration. This equation, F equals ma, means F, which is the net force, is equal to m, which is the mass, times a, which is the acceleration. When the mass increases, the acceleration decreases, and when the mass decreases, the acceleration increases. Since the force equals the mass times acceleration, the force and acceleration depend on how great the mass is. This person has to lift a glass. It's known for having a light mass. Since the acceleration and force is dependent on the mass, the force applied is small, but the acceleration is big. This person has to lift a TV. Compared to lifting the glass, the television's mass is much greater. Since the acceleration and force is dependent on the mass, the force applied is greater and the acceleration is smaller compared to the glass. Newton's third law. When one object contacts another, the force of that object will be the same as the other, but in opposite direction. Here we have a rock and a glass. We're going to drop the rock into the glass. This demonstrates when the water contacts the rock by dropping it, they go in opposite directions. If two objects of different masses interact, the greater mass will accelerate less after the interaction. When you compare water and a rock, the water has less mass. According to Newton's third law, the object with less mass will accelerate more. When the water and rock come in contact, the water overflows the cup and accelerates much more than the rock due to its smaller mass.